Okay, we have some similar figures, so we're going to be solving for some side lengths in this next foldable. So we have similar figures added to our table of contents onto line F, and it's going to be going on to page 58. So on the little flap is a little note. Just remember that when you have similar figures, you have corresponding angles that are congruent, and the ratios of their sides are proportional. So we have congruent angles but proportional sides. So that means fractions. Also, the other thing that's true about them is they can be created by performing one or more transformations. So remember, our transformations are our translations, that's sliding it around, reflections, rotations, and or dilations. Okay, inside. It says that the triangles are similar. So if these triangles are similar, then that means that we should be able to have congruent angles and also proportional sides. So if they tell you triangles are similar, or you see that they have angle or something like that labeled in the picture, then that means you can make fractions out of the sides and match them up. There's actually more than one way to match them up, but we're going to stick to matching the corresponding parts to each one. So we see the two triangles here, right? We have this yellow guy down here, and we have this blue guy right here. Okay, so they both have a right angle. Boom, boom. So we do know that the hypotenuses are going to be matching pieces, but there's no numbers on the hypotenuses, so we can't pair them up. We can also see on this yellow triangle, let's do yellow triangle over blue triangle. Remember, I always like to put a little note, yellow over blue. Okay, we only have information about two of the sides. We have this H, we have this, and we have this and this, and we don't have anything about the hypotenuses. So let's look at the smallest of the sides of the yellow one. Smallest of the sides, we have a 5.5 and a 3. So the smallest side we have is a 3. Now look at the other blue triangle. Which side is going to match up? Which side is the smallest side? It's this 24 down here, isn't it? So the 3 is going to match up with a 24. Those are corresponding sides. The next one we have is this 5.5, and that is this height right here. So that's on the yellow one, so that's a 5.5. That's going to match up to this height right here, which is an H. Now all we have to do is crisscross multiply to solve this. So we crisscross multiply. 3 times h is 3h is equal to, we need 24. 24 times 5.5, and I get 132. Last step, to get h by itself, I need to divide by 3. Divide by 3. 132 divided by 3 is 44. So h equals 44. So the height of this tree is 44. And that's all they ask us to find. Now, we could find these other measures because these are right triangles, so we could do Pythagorean theorem if we needed to get more. But it looks like we just need to find h. Okay, next picture. Okay, we have some similar figures, and we could tell we have this right angle on the side. We also know these are vertical angles. So these are similar by angle. So even though they didn't tell us these triangles are similar, they are, because we can see angle because of these vertical angles right here and the given right angles. Okay, so we need to see what we are going to match up here. So we have, let's talk about this. Let's just do the small triangle. We'll do the small one. Or maybe we could just do the triangle on the left over the triangle on the right. triangle on the left over the triangle on the right. It doesn't matter what you pick, just gotta stick with it, whatever you pick. So the triangle on the left, let's pick a side that we have on the triangle on the left. So we have this side right here. This is 17.2. 17.2. So what side does that match up with on this one? 17.2 matches up with this one, 52.4. Okay. And then that means this is our hypotenuse. We don't have our hypotenuse of either one. That means this D of the left one matches up with the 56.7 of the right triangle. And then we just have to crisscross multiply. So we multiply those together. That's 52.4D is equal to the other side. Let's see, we got 17.2 times, you should be doing this on your calculator. Let's see, I got 975.24. Okay, then to solve that, I got to divide this side by 52.4, divide this side by 52.4. So divided by 52.4. And I got D is approximately, D is approximately 18.61. And that is meters. So this side is 18.61. Let's see if that makes sense. So this is our smallest side, and then our next, this was our smallest side and our next. So it looks like this makes sense. Every time there's a picture, I like to put it in there to see if it makes sense. Okay, it says these rectangles are similar. Now we can clearly see that we gotta stand this guy up or something like that, right? Okay, so remember when they're rectangles, that the opposite sides match each other. So this is a 57, and this is an 8, and this is a 24. So that way we have plenty of things to pick from because rectangles have opposite sides congruent to each other. Okay, so we can do the left shape over the right shape. So this guy is my left guy, and this is my right guy. Left over right. Okay, so on this shape, what is my smaller side on this shape? The X is the smaller side. Okay, now my right shape, going over here, which is the smaller side? The smaller side is the 8, because I only got an 8s and 24s, so we're pairing up the two smaller sides. Okay, go back to the left shape. The next biggest side is the 57, and that has to be matched up with the 24. Crisscross multiply. X times 24 is 24x is equal to, I need 57 times 8. That's 4, 5, 6. Divide both sides by 24. Is 19. Okay, let's put that on our picture. So this is 19, 19. That looks good. That's the smaller side. We got a 57 and a 19, and a 24 and 8. Looks good. Okay, if quadrilateral dogs is similar to quadrilateral bear. Okay, so quadrilateral means 4 sides. 4 sides. Okay, so I'm going to draw something with 4 sides. It's going to look like that. Okay, so that is D, O, G, S. Remember, you got to go in order going around it. You could start wherever you want, but you got to go in order, either clockwise or counterclockwise. You can't go all zigzaggy. Okay, now I need to draw something that looks similar to that. So I need to try to draw the same shape, but maybe bigger. Okay, I drew the same shape. Now remember, bear is going to line up exactly to dogs. Remember how you could stack them right on top of each other. So where did I start with the dogs? I went D, O, G, S. So when I do bear, I'm going to do B, E, A, R. Okay, so I need to see which one of these proportions match up matching pieces. So let's go ahead and check them. Now remember, multiple choice are harder in math because you got to do 4 math problems. Okay, GS. G to S. Mat over DO. Okay, so we're doing this one over that one. Now what do you think that matches on the other picture? If I went from here to here, that means it has to be this one to this one, right? So that means I would have to have AR and BE. So this one actually works, doesn't it? Okay, so let's keep him. He's good so far. Let's see if we have another one. Okay, I'm going to actually erase it. You know what? I should leave that on there. Let me just pick a different color. Let's do green. Okay, if I'm going to check this one, let's see. If I want to check this one. DO, that's this piece, over SD. SD. Okay. Okay, so that's this piece over that piece. Now, on the other picture, what does that have to match? This piece over that piece. So that means it has to be BE over this piece, BR. So BE, that looks good. But what about this? No, because if we went this one over that one, we would have to do this one over this one. And AR is down here. So this one is not going to work. Let's look at this one. Let's pick a new color. I'll do this gray. OG. OG is right here. OG. DS. OG. DS. Okay, so that's this right side over this other side. Okay, over here we need, well, look what they do. They go down here. Nope, that's not going to work out, right? This is jacked up because it's going to have to be something with EA over BR. So this bottom looks good and this top is messed up. So this one does not work. Let's look at this last one. So SD. SD is this piece over AR. SD over AR. Okay, so they went here over there. And then they did OG over EA. How's that? No, it looks like the OG over EA do match up, but this piece does not match up with that. So this one is a little bit messed up also. So the first one we tried obviously is the best one. Now, did you see what they did? Now, traditionally, we like to put like this side over this side, like one shape over the other, but they're a lot. Do you notice how they did that? They picked 2 sides on this one, and it's still going to match up to 2 sides on this one, because when you crisscross multiply, you're taking different parts. So as long as you're matching up corresponding parts in the same way all the time, then you're going to be able to have nice proportions. Okay, this one here. Triangle ABC is similar to triangle PQR. So ABC is similar to PQR. You see how I like to do that? Because these are too spread out. I like to stack them. Which proportion can be used to find N? So let's check out this one. I'm going to do all colors. Remember, multiple choice are sucky. So the 8 is right here. 8 over 9. 8 over 9 would have to match which pieces? You got to think about flipping him upside down. Now, if you want to flip him, actually, he is flipped and flipped again, right? So this is the 8 over the 9. So that's the long side over the hypotenuse. So in this picture, what's the long side over the hypotenuse? That's the 24 over the N, right? We could even label these like hypotenuse. And this is the long side and the short side. And so this would be the hypotenuse. And this would be the short side and the long side. Maybe that will help us because this one was the L over the H, right? But then when they went to this one, they did the H over the S. So that one's not going to work out. Let's check the next one. The 8 over the 12. So that is the 8 from the small one. That's the L from the left triangle, over the 12. Long over the small. And then N, they did the hypotenuse over the hypotenuse. Seems to be messed up over here, doesn't it? So this is probably not going to work out either. Let's check this one. 4 over 8. So that is the short side over the long side. Now let's see if they did short side over long side here. 12, that is short. Long, the N is the H. That does not work out either. Does not match. Let's check this last one. 4 over 9, that is short over hypotenuse. Short over hypotenuse. 12, short, N, hypotenuse. See how that one works. Set up the same way. You see how you guys put some codes on this? Now, sometimes when they are oriented the same way, you can just see like, oh, the bottom and the bottom. But this guy is like flipped and backwards. So that's why I decided to do hypotenuse, short, long. And you could do it like small, medium, large. You could do whatever you want. Just kind of label them so you see what's going on. Okay, and this one. These trapezoids are similar. Okay, so we're missing some stuff. So see, these ones are oriented the same way, so you could actually see what's going on. So that means this 10 matches this 15. This 14 matches this 20. So I can easily say I'm going to do the left shape over the right shape. Okay, so left over right. So that means 10 is over 15. 14 is over 21. And 8 is over X. And I don't need to do the last side because it's exactly the same. And okay, so when I solve proportions, I actually only need to use 2 of these fractions because I have to crisscross multiply. And I'm obviously going to want to use this guy right here because he has the X in him. So maybe I will just use these 2 and not even bother with him. Now, I could have done the 10 over 15 in that one, but these 2 are nicely lined up next to each other. So I'm going to go ahead and do these 2. So 14 times X is 14X. And then I have 21 times 8. 21 times 8 is 168. And I got to divide both sides by 14. 168 divided by 14 is 12. So I've got X equals 12. See if that makes sense in my picture. Looks pretty good because I have this 14 and 10 and the smallest side are this, and I got this 21 and 15 and my smallest side is 12. So that looks fabulous. Okay, Hakan is standing next to a building whose shadow is 15 feet long. Hakan is 6 feet tall and is casting a shadow 2.5 feet long. How high is the building? Okay, so we have a building. Pretend like this is the building. And we have, pretend like this is a super tall building. Look at all these lovely windows. That's my building. The shadow. So the shadow, this is the shadow down here, right? Pretend like the sun is over here. Okay, it's shining and the shadow is here, is 15 feet long. Okay, so we can see our little triangle, right? So this is my fake triangle right there. Okay, then we have Hakan. Hakan is right here. Okay. He is 6 feet tall, so this is 6. He is casting a shadow. Here's his little shadow. Is 2.5. Okay, we can see both our triangles, right? Okay, and we can see, and it says, how high is the building? So we are looking for the height of this building. So we can easily make some fractions. We could do the left triangle over the right triangle, or Hakan over. We could do Hakan over the building. Okay, so Hakan's smallest side is 2.5. And that goes over the building's smallest side, which is the shadow. That's 15 equals. Then we have the height is 6. And then we have the height of this building, which is what we want to find, and we'll call him x. So crisscross multiply. We've got 2.5x is equal to 15 times 6. That is 90. I'm going to divide both sides by 2.5. So 90 divided by 2.5. And we get x equals 36. So this building appears to be 36 feet tall. And the last one, find all missing links. So once again, we have this triangles inside of this triangle. So we do have this reflexive property over here, right? So we do have these two triangles. This pink triangle is similar to this blue triangle by angle. We also have these parallel lines, which we could have done this angle at the top. Remember, this angle is the same as this angle, because they're also corresponding, because we have these parallel markings. Okay, so let's look at this pink triangle. This pink triangle has all 3 of its sides already. This blue triangle, looks like this blue triangle only has this one side. But it looks like the ratios of the pink, you want to do pink over blue? Pink over blue. See how colors come in handy? So what side corresponds? So this 8 corresponds to this 12. So let's do pink triangle is 8 over 12. Those definitely match. 8 over 12. Now let's pair it up to these sides, because we have the 5. That's the pink one, right? Now we don't have this side right here. So let's call this side x. And because we could find that, because that way we could figure out how long this is, and then we could even figure out this little part, because if this is 5, we could figure out the rest. So let's go ahead and crisscross multiply this. So 12 times 5 and 8 times 6. 8 times x, so we have 8x equals 60. Divide by 8. So we have 60 divided by 8 is 7.5. X equals 7.5. So that means this whole length is 7.5. So if this part's 5, if we just take 5 away from that 7.5, that means this little piece up here is 2.5. Does that make sense? 2.5 plus 5 do make 7.5. Okay, now we need to get this piece down here. Okay, so we already know pink to blue. We already know that pink over blue. I'm going to use the nice pretty sides that we already started with. The pink to blue was 8 over 12 for these two pieces. That's the nice pretty one. I'd rather not use decimals if I don't have to. We need pink over blue at the bottom. So at the bottom, this side is 10, so that's pink, right? And this piece right here, we don't know, so let's just call it that y. Okay, we've got crisscross multiply. So we're going to end up with 8y equals 12 times 10, which is 120. And we need to divide both sides by 8. So 120 divided by 8. A little bit out of space down here. I'm going to get y to equal, because we're going to divide by 8. Divide by 8. We're going to get y to equal 15. So that means this whole side is 15. And so obviously if this part of it is 10, that means from here to here has to be 5. And I think we found all the missing links. Okay, this glues on page 58.